Hi and welcome. In this video, we are going to see about March Long Challenge 2020 on CodeChef. Okay, so this is Pintu and fruits question. So the question says that chef went to Australia and saw the destruction caused by bushfire, which made him sad. So he decided to help the animals by feeding them fruits. First, he went to purchase fruits from Pintu. Now Pintu sells m different types of fruits. Okay, for example, m value is 4, so he sells 4 different types of fruits. Fine, he sells them in n baskets. So here n is 6, that means we have in total 6 baskets, where each valid I, the ith basket cost pi. Okay, so for each valid I, the ith basket, so if we have 6 baskets, so 1 2 3 4 5 and 6, so if we have 6 baskets, the ith basket will cost pi. So the first basket cost 7, the second basket cost 3, the third basket cost 9, fourth basket cost 1, and so on. Fine, and it contains fruits fi of type fi. So how many type we have? 4. So we have 1 2 3 4 type of fruit. Okay, so each basket will contain one type of fruit, and its cost will be given to us. It will contain one type of fruit and it will cost will be given to us. Okay, chef does not have too much money, so he cannot afford to buy everything. Instead, he wants to choose one type of m available. Okay, so in this we do not have all the 4 types available, we just have 1 2 and 3 types available, correct? So he will choose any one of the type that is available and purchase all the basket containing fruit of that type. So if we select to choose the type 3, so he has to purchase all the basket of that type. So that means he has to purchase the third basket and the fourth basket. The third basket will cost 9 rupees and the fourth will cost 1 rupees. So in total he will give 10 rupees. Okay, if we choose the second basket, that means the type of the basket containing type 2, so he has to choose the 3 rupees basket, this one, and the 1 rupees this, and then 1 rupees the last one. So total 5 rupees he has to give. Okay, and if we choose the basket which is of type 1, so he has to give 7 rupees only. Fine, so he has to choose any one of these, correct? Now help chef choose the type of fruit to buy such that he buys at least one basket and the total cost of the basket he buys is the smallest possible. So in this, what is the smallest possible total cost? It is nothing but 5. Okay, 5 is the smallest possible total cost when he chose the type 2, correct? Type 2 basket. Fine, so in this particular example the answer is nothing but 5. Remember, he can only select from the available type basket. We do not have a type 4, so he cannot choose from type 4, correct? Only the available baskets are possible. Fine, so let's see the constraints. So the constraints here are t of 1000, okay, m and n less than equal to 50. Fine, so the fruit type can be from 1 to m. Okay, m type of fruits, so the fruits can be from m to 1 to m, and the price of the basket can be from 0 to 50. The price of the basket can go 0 to 50, correct? Now m equals to 2. Now here is the test case that I have explained to you, and its answer is nothing but 5, the minimum cost. Fine, so according to this constraint, even if we go till 50 into 50, that is n square, and multiplied by 1000, okay, so it is nothing but 2500 multiplied by 1000. Okay, it is nothing but 10 to the power 5, 25 into 10 to the power of 5. So it is still in the range of 1 second. Okay, so we can have n square approach also, but we will not have n square approach. We will be discussing the order of n approach. Okay, so let's now discuss what are the different cases in this particular question and how to deal with that. Fine, and how to approach the implementation. So let's see this example again, and it is a very simple this logic. Okay, we just need to take care of few points. So for the type 1 we have the value as 7. Okay, for the type 2 we have the value as 5, and for the type 3 we have the value as 10. So if using a data structure, using an array, using a map, we can store this, that at index 1 the value is 7, and index 2 the value is 5, and index 3 the value is 10, and from this particular data structure, whatever you are using, we get the maximum value. That's our answer. So a simple logic and simple implementation, there is not much thinking about this one. Okay, so if we have the values as 1 1 3 2 2 3, okay, just 3 case, m value is 3, okay, and the values are nothing but 2 5 6 7 8 1 2. So let's see. For the index 1 we have the values as 2 plus 5 as 7. For the index 3 we have the values as 9, and for the index 2 we have the values as 9. For the index 2 also we have the values as 9. Okay, so which one to select? We will select the one which is having the minimum case. Okay, that is nothing but 5 plus 2 is 7. Fine. So this is how we are going to approach this question, that using an index array, using a frequency array. Okay, at each index, because the frequency array is nothing but till 1 to 50 only it will work, just 50 size array. Why? Because m value maximum can be 50, so just a 50 size array. Okay, at each index we will be storing that what is the value, that is 7, 5, 10. Fine. Now we have to also consider the case of 0. We have to also consider the case of 0. That means that if all are 7, 5 and 10, what we can do is, in the index array we can have -1, -1, -1 in the beginning. Okay, and then add all these values. So in between we have 7, 5, 10, then -1, -1, -1, and we will have the minimum value as 5. We will not consider -1 using an if else condition. But okay, this will have is all on implementation problems. Fine. What if we have a 0 here? Because it is given in the constraints that pi value, the price I value, can be 0 also. Okay, now if we consider, instead of -1 all things as 0 in the beginning, if we just initialize this array as 0. Okay, and in this 0 we start adding whenever 1 comes. For here, for example, in 1 increment 2, then 1 comes again, then increment 5. That's fine. For 3 now increment it to 7, for 2 increment it to 8, then 2 comes again, so increment it to 9, and then 3 comes again, so increment it to 9. Fine. Now if we ignore all the zeros, using an if condition, okay, and just count the value which are non-zero, what is the minimum in it? So 5 is the answer. Okay, we are done. 5 is the answer. We are not considering 0. But this case was when the m value was 4, and in the array we do not have this 4 at all. In the array we do not have this 4 at all. Okay, we are not having a basket which is containing a type 4. Okay, so therefore if it is any value we are not considering it, because it is not even present to be considered to. Okay, but what if the example is 1 2 1 3 4 3? Okay, and in this particular case the values are 4 2 1, okay, 1 0 1. Now what we are going to do, because pi equals to 0 is acceptable. Now in this particular case, if we have an array, okay, and this array contains zeros in the beginning, okay, now in this particular one, 1 will be changed to 4, 2 will be changed to 2, 1 will be changed to 5, then 3 will be changed to 1. Now 4 will remain 0 and 3 will be changed to 1. Okay, now in this particular case, now if I go with the same logic that ignore 0, okay, the minimum value that we should have considered was 4, because 4 value was 0. Okay, but we will be answering 1 because we are ignoring the value of 0. Okay, so just for the implementation, you can implement it your own also. Fine. In your frequency array this case will arise, so therefore I am just telling you about that. Fine. So in this particular case, if my basket type is present, okay, that means we have to select it, we have to consider it. If the basket type is not present, then do not consider it, it is fine. But if a basket type is present, then we need to consider it in our calculation, even if it is 0. Okay, the answer can be 0 in this particular question. Fine, that is what the point was, the answer can be 0. Okay, so now in this particular case the answer is nothing but 0, that because 0 is the minimum cost for the type of 4. If 4 was not present, then that is a different case. Now 4 is not present, it is not even present to be considered. Okay, so therefore in this particular example, now the answer will be nothing but 1 plus 1 2. Okay, now the answer will be nothing but 2, that is 2 is the minimum cost, or 1 plus 1 2 is the minimum cost. Understood? Done. Now how do we handle it? How do we handle whether 4 is present or not? What I have done is simple. I have used a boolean array, a boolean available array. Okay, now if any this particular m is available, I make it true. It is also of size 50. If it is not available, I make it false. Okay, very simple. So 1 will be true, 2 will be true, 3 will be true, and 4 will be true. Okay, now when I just traverse this array, okay, when I just traverse it array, I consider this one available array. If available is true, then I consider that particular value. If available is not true, I do not consider that particular value. Okay, now in this 4 available is true, so I consider 0 in my minimum calculation. Okay, I consider 0 in my minimum calculation. That's simple. Okay, now if 5 is false, so I do not consider that. If 5 is false, I do not even consider it inside that into my calculation. Okay, so we have how many? 2 arrays, for a frequency array and an available array. Okay, so how the implementation will look like? First, we will take all the inputs, whatever the inputs are. Then after taking all the inputs, we will have a frequency array of from 1 to m50. Okay, so we need 50 index, therefore m plus 1. Then third is nothing but our which array? Available array. This is a boolean array of size m plus 1. Fine. Then we will fill our frequency array and our available array. How? For I equal to 0 to I less than equal to n, I less than n, I plus plus. That means I am traversing my array that is containing the basket. So 1, 1, 2, 3, 4, 3. Let's say this is my array. Fine. So now frequency of my f array of I equals plus equals to pi. Correct? Whatever the values are, I am just adding it into the frequency array. So if it is 1, so 1 plus 7 is added. Correct? In the frequency at that particular index, 7 is added. And my available array, available of f of I will become true. That's simple. Now if I value is nothing but 0. Okay, so f of 0 is nothing but 1. So frequency of 0 equals to 7 right now, and the available of 0 equals to available of 1 equals to true. Okay, because f of 0 is nothing but 1. So frequency of 1 will become plus equals to 7, and available of 1 will become true. Now similarly, when I will increment, it is again 1. So 7 plus 8 will become 15 at frequency of 1, and it is already true. When it comes to 2, so now it is f of 2, which is nothing but 2 itself. So frequency of 2 will become 1. Frequency of 2 will become 1, and available of 2 will become true. That means true 2 is available. Okay, now same for 3, for 4, for 3 again. Correct? Now in the frequency array, at each particular element, so each particular element is now converted into an index in the frequency array. Okay, it is stored that whatever is what is the value of its summation pi. Correct? And the available array will tell us whether that particular basket is even available or not. Now after this, just using a for loop, I am going to check 2 conditions. Okay, what will be the conditions? That available, first one is available should be true. That means the basket should be available. The basket should be available. Correct? Now just using this condition, if the basket is available, okay, and we have to check for our minimum condition. That means the value should be minimum. Okay, the value should be minimum. So if the minimum is less than the current value, then we have to update the minimum. Okay, that's simple. Let's see the implementation now, and we are done. So in this particular case, taking the inputs nm, okay, then taking the f input and the p input, then frequency array, then available array. Okay, available I make it false, frequency I make it 0 for all the cases. Okay, then this is filling my frequency and available array. Okay, then using the min, then in this one we are updating the, if it is min is greater, then we are updating the min, if only if the available of that particular case is true. If the available is true, we are updating the min, and finally we are printing the minimum value. The only case here to handle was the case of 0. Okay, in the implementation, because we are using a frequency array. Okay, therefore in the implementation part we need to handle the case of 0. Okay, that was the only case that need to be handled in this particular question. Fine, a simple straightforward logic. Anyhow, thank you.